integral 0 to 2 plus I z bar the whole square dz along real axis to 2 and then vertically to 2 plus I. Also along the another path along the line 2y equals x. First let's just examine the first path, that is along the path real axis up to 2, from 2 vertically upwards to the point 2 plus I. So we have the point P 2 plus I, which is represented using x coordinate 2 and y coordinate 1. This is point A, which lies on the x axis or the real axis with x value 2. Now we are moving along this path OAP, and when you consider the integral 0 to 2 plus I z bar the whole square dz, we have integral splitted to two paths, integral along OA and integral along AP. When you consider the path along OA, we have y equals 0. Therefore, dz reduces to dx only, because dx plus I dy becomes dx plus I 0. Therefore, dz equals dx, and x ranges from 0 to 2 along the path OA, because x is ranging from 0, 0 to 2, 0. Therefore, x varies from 0 to 2 in this path OA. In OA, we have integral over OA z bar square dz written as integral 0 to 2 x square dx, because z bar whole square can be rewritten as x minus I by the whole square, which when expanded become x square minus y square minus 2i xy. Along OA, since y becomes 0, we have these two terms becoming 0. So x square is the only non-zero term. Therefore, along OA, we have the integral reduced to this expression. After integration, we get it as 8 by 3. Now along AP, we have x equals 2. This is the line which is parallel to y-axis and has the equation x equals 2. Here dz equals I dy, and y ranges from 0 to 1, because y coordinate of A is 0 and y coordinate of P is 1. Therefore, y ranges from 0 to 1. Here x equal to 2, therefore dx becomes 0. That's why dz equals dx plus I dy can be written as 0 plus I dy, or dz can simply be written as dz equals I dy. Now along AP, when we try to evaluate the integral AP z bar square dz, we have x equals to in this expression. So this expression becomes 2 square minus y square minus 2I into 2y, which can be rewritten in this format. Now in place of dz, we have to write it as I dy, and after usual integration and application of upper and lower limit, we obtain the final answer as 2 plus 11 by 3i. In order to get the complete integral 0 to 2 plus I of z bar the whole square dz, we have to sum these two answers, that is 8 by 3 plus 2 plus 11 by 3i will give the final answer. So along the first path OAP, we have the integrals answer as 14 by 3 plus 11 by 3i. Now let's evaluate the integral along the second path line 2y equals x. We have 2y equals x is drawn roughly like this, with 0, 0 represented using O, and the point P with x coordinate 2 and y coordinate 1 represented here. Along OP, we have 2y equals x, therefore dx equals 2 dy. Therefore dz equals dx plus I dy can be written as dz equals, in place of dx, 2 dy plus I dy. Here dy can be taken outside, therefore dz becomes 2 plus I dy. Now we have y changing from 0 to 1, which is visible from the graph itself. Y coordinate changes from 0 to y equals 1. So the integral can be rewritten as integral 0 to 2 plus I z bar square can be replaced by the expression x square minus y square minus 2i xy into dz, and dz can be replaced by 2 plus I dy. Now wherever x appears, replace it by 2y, because we are going to integrate with respect to variable y, and we have written the limits of variable y. So we will convert every x term in terms of y. We have to rewrite x as 2y based on the equation given. So after we have replaced x by 2y, we obtain this expression, and we have this rewritten as 3y square minus 4iy square. When y square is taken common outside, we have 3 minus 4i into y square. Since 2 plus I and 3 minus 4i are constants, those terms can be taken outside integration, and inside integration we have y square into dy. After usual integration and multiplying these two factors, we obtain the final answer as 10 by 3 minus 5 by 3i.